Let's take a look at some trig. We're going to be talking about degrees and radians, ways that we would measure angles. We're going to talk about the trig ratios, sine, cosine, and tangent, and we're going to use those to solve triangles. So to give us a bit of background, what's an angle? So we're going to have two arms or rays, and they are going to share a common endpoint or a vertex, which is this little point right here on both of them. And the angle, let's say on this first one, is between the two arms. So here's an angle here. But we could also measure an angle around the other way, as long as you are measuring where this little symbol is, but you are fine. How do we measure angles? So we can use degrees, which is what most people are used to, or we can use radians. So degrees are that kind of 360 as you spin in a circle. They're kind of base 10. They look like time. We use them in actual applications. So if you're measuring degrees and you're building or doing something like that, you're going to report a degree. Now, if you're going a little further with your math, doing calculus, thinking about graphing trig functions, then you're going to use the SI unit, which is radians. To look at how they change. Now, notice that I am starting 0 degrees right here, and I'm starting 0 radians right here. And that's going to hold true for this whole unit. We're going to kind of measure from what will become the positive x-axis, and as we count up, we will spin counterclockwise to get increasingly large. So things we know, 90, 180, 270, 360 are familiar measures for degrees, correspond to pi over 2, pi, 3 pi over 2, and finally 2 pi radians. Now the radian is just kind of a measure. 1 radian happens when you have 2 radii, and the distance between them is an equal length, and then you've got 1 radian. Not to scale by me. Okay, and when you use radians, we generally leave the symbol pi inside. We keep it exact, so we keep these fractions with pi. When we measure degrees, that's when you see the decimal points. If we were doing different applications, we might talk about degrees, minutes, and seconds, but we're not going to for this. All right, so what do we need to know? We need to know how to convert between degrees to radians and back again. So all you have to do is take your measure of degrees, and notice whenever you're in degrees, you have this degree symbol. That will come into play a little bit later again. So if I want to convert to radians, I take 325 degrees. And then I'm going to multiply by the fraction pi over 180. And I always think of that as being like I'm putting pi into the measurement, so I'm making radians, which often have pi in them. So my first step is I get 325 pi over 180. Now, if you can, you owe it to me to reduce this fraction. So here, both of these numbers are divisible by 5, so I can reduce the fraction to 65 pi over 36. So not touching that pi symbol, and this is in radians. So just quickly looking at a couple more. Take the degrees, multiply by pi over 180, get an initial fraction, and then if you can reduce. Now 45 happens to go into 180 evenly, so we're going to change that to 1 and change that to a 4, and we see that 45 in radians is pi over 4. And our second example, same thing. First step, just writing it down and then reducing if you can. And I believe these are both going to be divisible by 4. Oops, sorry. Divided by 4 makes 61, and dividing by 4 is 45. And we're not going any further with that. Okay, so we've taken angles in degrees and turned them into radians. Now let's go the other way. So this time, we're going to multiply again, and we're just going to flip the multiplier. So basically we're dividing by what we multiplied before, but you don't have to think of it that way. So we're just going to take our angle in radians, and in order to make it into degrees, we multiply by 180 over pi. So it's like we're canceling out that pi value, taking it out of our equation. So we start here, and you can actually cancel with the numerator and denominator of different fractions here if you're just going to multiply. So I'm going to change this to a 1 and change this to a 90, and then all I'll have left is 5 times 90 equals 450 degrees. Putting that sign in so I recognize this is a measure in degrees and not a measure in radians. And looking at a few more examples of that, we're going to take this mysterious angle, 4 pi over 7. We will multiply it by 180 over pi. And in this case, canceling what I can or reducing where I can, the pi's are going to cancel. I'm not going to be able to do anything there. So I'm just going to do the math. I'm going to go 4 times 180 divided by 7, and that will give me 102.86. So using decimals with degrees, and that's done. Okay. Number 2, we have 5 pi, and we're going to multiply it by, looking at it like that, 180 over pi. Once again, my pi's will cancel, and I have 5 times 180 divided by 1, and that's going to be a nice number, 900 degrees. Here, I don't have a pi symbol. That's fine. Sometimes radians don't have a pi measure. It could be decimal, but we just proceed the same way. So basically, my math this time will be 3 times 180 divided by pi. Because I didn't cancel out that pi, I have to leave it in the equation, and it gives me a nice gross 171.89 degrees. Okay, so these trig ratios, we have 3 primary trig ratios we call sine, cosine, and tangent, and all they are basically a decimal that's created when you compare different sides of right-angled triangles. So I'm going to touch on this quite a bit. When we talk about a right-angled triangle, we have 3 sides. Now, the hypotenuse is always the longest side. It's always directly opposite the 90-degree angle. Okay, and then we have something we call the opposite and something we call the adjacent side. And those are dependent on where your angle is. So if I'm standing at this corner of the triangle, adjacent means beside. So the side that touches my angle is going to be my adjacent side. And the side that I see opposite me, like as if it's across the room, I'm standing in a corner and it's the wall across the room, is my opposite. So just always knowing how to label that correctly. You're not going to mess up the hypotenuse, but you will get spun around by the opposite and the adjacent. And now the thing is, if we have any measure, some angle here, we use this theta symbol a lot for angles, and if these are the same angles, then the ratio between the sides will be the same in these triangles. Yes, this triangle A will have smaller sides, but they will be similar. It'll be a similar triangle to triangle B. Because we know if there's a 90-degree angle and this bottom corner angle is the same, then the third angle must also be the same in the two triangles. So that's all trig ratios are. Sine is a ratio between the opposite side and the hypotenuse for any angle. Likewise with cosine and tangent, just different parts. Okay, so how do I find the value of a primary ratio? How do I find that fraction? It's from a graph or a lookup table, so it's not something you're going to do math to get. You're just going to use your calculator. Now, the first step is make sure if you're working in degrees that your calculator is in degrees, or else it's not going to do it right. So you should have a DRG button or something similar, and when you look at your display you should see DEG, DRG, not rad or grad up on the display, because then you're working in radians or gradients. That's completely different. Okay, so what do you do if I want to know what the sine of 23 degrees is? I press the sine button, and then 23, or maybe in the opposite order, depending on your calculator, and it's just going to spit out the value. So what is 0.3907? It is the ratio of the opposite side over the hypotenuse. So whatever the opposite is, the hypotenuse is, like, it gives you this thing when you divide. And you can take negatives too, that's fine, just punch them in properly. Okay, so the last thing I want to mention on this slide, because it comes up, is what is the difference between sine 23 versus. So if you are taking this first one, that is the sine of 23 degrees. The second one, when there is no degree symbol up here, then that is radians. So you have to switch your calculator by pressing that DRG button into RAD on your display, and then you do sine 23. It will give you a completely different answer. Bear that in mind. All right, so we have our 3 primary trig functions, and then we have 3 reciprocal trig functions, okay? All they are the flipped of the ones, and they're just irritating because they don't go with the ones you expect them to. So if you were to take the reciprocal of sine, you would end up with cosecant. So if sine is opposite over hypotenuse, that just means that cosecant is hypotenuse over opposite in that triangle. Likewise, secant is hypotenuse over adjacent because it is the reciprocal of cosine, which was adjacent over hypotenuse. And cotangent is the reciprocal of tangent. So instead of taking opposite over adjacent, we take adjacent over opposite. Okay, to find the value of these reciprocal ratios, we don't have these buttons on our calculator. Like, I can't just be like, I'm going to press the cosecant button and then 75, and it's going to give me the answer. Okay, but what you do know is this fact. So you're allowed to just find the value of sine 75. So you can say that cosecant 75 is going to be the same as 1 over, press that stuff on your calculator, it's going to spit out this value, and then you can do that math, 1 divided by 0.966, and you will find that cosecant is equal to 1.035. Okay. Option 2 is be very careful. You can just do sine 75 in brackets and then use your this button, or might be that, or you can actually physically type in x to the y with a -1, and that does the reciprocal for you. What you have to be very careful is that you don't use, because that is different. That's what we do to find angles. That's the inverse, okay? So if you're going to use this kind of one-step process, be careful. And I would suggest checking your work before you go off willy-nilly with that, making sure you've got the difference. Okay, so sometimes we're going to have a trig ratio. Like, we'll have a triangle where we have 2 sides, and we can divide those 2 sides and get a decimal, and we want to find an angle. And if we do that, we're going to use the inverse button on our calculator. So these are the ones that look like sine -1, cos -1, tan -1. So we call those arctan or inverse, and we can find them as our second function. So usually you're going to hit that second function, and they'll be sitting as the option right above sine, cos, and tan. So you might see something like sine, and then written above it is this. So in order to use this function, you are going to hit second function first. Okay, so if I want to find an angle, and I was told that the tangent is 0.1372, press this button, input this number, it's going to spit out if you're in degrees, and it finds that angle for you. Okay, so let's make our way around these things. So A, very straightforward, just pressing it on your button, calculator, making sure you're into degrees, and the calculator will return this value. You are not finding this, you're just pressing it into your calculator. Question B, notice there is no degree sign, so switch your calculator to radians, because this is a very big radian number. And then do the same thing, press sine of 885, and this time it's going to return a very different number. and that's fine. Question C, we are looking at, oh, look at that, I've got two C's. We are looking for a cotangent, so I don't have that button in my calculator, but I know that the cotangent of 36 is going to be the same as the reciprocal of tan 36. So in that case, you can do it in 2 steps. Find tan 36, just to be safe. And then when you do that math, 1 divided by 0.7265, you get 1.3764. Okay, so looking at the second part, C number 2. We're looking for the angle. So when you're looking for that angle, you use that second function, that arc cos, or the inverse, and the math you're going to do is because this 0.5431 represents adjacent over hypotenuse. The math has already been done for that, so we just need to punch it in and find out what angle made that happen. And it should give you 57.1 degrees. Once again, cosecant is equal to this number. So this time I'm going to set it up like cosecant is been found for me. And I know that is equal to 1 over the sine of some angle. So if I cross multiply, I know that 1.496, I'm going to drop the 0, sine theta equals 1, which means that sine theta equals 1 over negative 1.496. And in order to get that angle, it's getting very tight in here, we are just going to do theta equals this math. Sine to the negative 1 of 0.6684, which is 1 divided by negative 0.1496, and you're going to get an answer of negative 41.9 degrees. So it can get very confusing sometimes, so really try and get what they're asking you for. All right, let's look at E. We're given a tangent. Now we could go tan to the negative 1 and find the angle, but we don't need to because we just want the cotangent, and we know that's equal to 1 over tan theta. So if tan theta is negative 3.2511, that's all the math I need to do. And I'm going to get negative 0.3. There we go. Now, I'm going to change colors because I've made a lot of mess in here. I'm going to try and give myself some room. There we go. So this time, I have tan of theta, so I'm going to find the angle. So first I'm going to find the angle because I have to go into another kind of trig ratio. So it's best to start by finding the angle. I take that arctan, just pressing another calculator, and I find out that my actual angle is 72.9 degrees. Cool. All right, I want secant. Secant goes with cos. So all I'm going to do is use my cosine button to start. And when I do that, it's going to return. And then all I'm going to do is find secant by doing 1 divided by 0.2940, and it's going to be 3.4014. So the math isn't hard, but it can be confusing. Let's get back to triangles. So we've already spoken about labeling triangles to get ready to do trig things. So you always have that right angle, hypotenuse. Doesn't matter how the triangle's lying. The hypotenuse must be across from the right angle. And opposite and adjacent can change. So if I'm sitting, let's go multiple colors this time. If I'm sitting here at theta and I look across for theta, this is my opposite side. And this is my adjacent side. Okay. However, if I move over and I go to this one, this angle, fish, alpha, suddenly if I want to make an opposite, it's here. And if I want to make an adjacent, it's here. touching that angle. So it matters where you are in the triangle. So don't move around, commit to one angle, and go from there. Now, use one of the two acute angles. Don't use the right angle. You're not doing math with tan and 90 and so forth. Okay, the second way that you should remember to label a triangle is by its name. So say this triangle was triangle PQR, and I told you that Q is equal to 90 degrees. So that means I'm committing to this angle being Q. The side opposite the big letter angle is the lowercase side. So little q is the side opposite big Q, the angle. They didn't tell me any information, so this one could be P, let's say, and this one could be R. And once again, side R doesn't touch angle R, it's opposite, and it's a small letter. And side P doesn't touch angle P, it's opposite, and it's a small letter. So just knowing how to label a triangle properly. Okay, let's start mathing. Put in my right angle, understood. So we've learned this a long time ago. If we have a 90-degree right angle, we can use Pythagorean theorem. And usually they just say c squared equals a squared plus b squared, but I mean, it could be anything. You think of our old triangle we just did, I think we had Q, P, and R, maybe it was like that. So if you wanted to solve for this side, you would have Q squared equals P squared plus R squared. And the only stipulation is this side, C, or whatever you're going to call it, must be the hypotenuse. And it doesn't matter about the two legs. They can be here or there. However, if you did want to solve for B, you would have to use B squared equals C squared minus A squared. Okay? Because if you have that information, if you've had the hypotenuse, you're going to be using subtraction. So let's see that at work. My first triangle here, number 1, I am looking for the hypotenuse, so I know I'm going to be using c squared equals a squared plus b squared. So I'm going to go with x squared equals 6 squared plus 8 squared. Respect your order of operations. Do the squaring first. After you square, you can add. So if x squared is equal to 100, I need to undo the square. You're going to do that by taking the root of both sides. So x is equal to root 100. And if you put that into your calculator, x is equal to 10. Okay, looking at the second example, number 2. This time we have the hypotenuse, so my math looks a little different. My unknown is one of the legs, so x squared is going to equal 20 squared minus 14 squared. Don't throw that away. Do the squares. Then we are going to do the subtraction. Now at this point, we know that x is equal to the root of 204, and it depends where you're going from here. If you're doing like mathy stuff, you might leave it as a radical. This is exact form. But if this was something you're actually measuring and building, you would find the root and have a decimal. So watch for what the question is asking you for. So we can use that theorem in combination with right angle trig to find all the information about a triangle. So here's the deal. You will be given two knowns and you've got to find an unknown. So you could have a hypotenuse and an adjacent, and then you're using it to solve for the angle. Or you could have an opposite and an adjacent, and you're using it to solve for the hypotenuse. That would just, you wouldn't even have to use sine, cosine, tangent for that one. You just use Pythagorean theorem. Whoops. And you could have, which one haven't we done? An angle and a side. And then you can use it to find another side, either this side or that side. How do we do it? Casatoa or Casatoa? So this is just a cheat to remember how it goes. It just tells you that cosine of any angle is the ratio between the adjacent and the hypotenuse. Okay, so you can also write it, some people like to write it like this. And then so is a ratio, sine is between the opposite and the hypotenuse, and tangent is a ratio opposite over adjacent. So there's our acronym, Casatoa, and I write it down every time I start to do trig. So let's use Casatoa to solve for sides and angles. Write it down so I know. Step 1, label your triangle. Okay, I've been given 41 degrees, so this is where I'm sitting. And I'm going to measure everything relative to this. Well, side x is the hypotenuse. The 12.3 is adjacent. That side is touching the 41, so it's the adjacent side. And this side, this vertical thing that we don't really need, is the opposite because it's across the room from the 41. So basically, I have two pieces of information, which are an angle and an adjacent side, and I want to find a hypotenuse. So I look up to Casatoa, and I find which things relate adjacent and hypotenuse. So I see A and H happening here. If it's A and H, I'm using cosine, C for cosine. So basically, I write cosine, and the angle always goes with that, is equal to, and it tells me up here that it's going to be adjacent divided by a hypotenuse. So there we go. This is the math I have to do. Okay, so first we're going to cross multiply. And then you'll get so fast at this. And then we're going to divide out the cos 41. And notice I haven't found the value to the last step, so that I can do all the math in my calculator all at once. So I just type in 12.3 divided by cos 41, and it will give me 16.3. So that means this side here is 16.3. So now let's find an angle. Obviously, this is where we're going to be sitting because that's the angle we care about. We have a hypotenuse, and we have an adjacent, and we have the opposite. So once again, two pieces of information, one thing unknown. I'm dealing with adjacent, hypotenuse, and angle. So I'm using cosine again, but this time I don't know the angle. So when I write it down, I start here, and then I have my adjacent, 7.8, divided by my hypotenuse, 12.9. Okay, and we'll do this one a little slower. You can do all the math in one step, but I'm going to do 7.8 divided by 12.9 to some degree of accuracy. And now the step to get an angle, remember, you use that second function cos, or the arc cos, and type that in, and that takes you from the ratio back to the angle. And this is what you should get. All right, let's look at another example. So say I'm standing on the ground, and I notice that when I look up, because I have some kind of tool that measures it, if I look up at an angle of elevation of 50 degrees, I see a plane, and somehow I measured that it's 12 kilometers away from me, from the ground to the plane. So I'm looking for how high it is, so I'm looking for this measurement. So label your triangle relative to that 50 degrees, and think about what you need. So let's write down our little cheat. I'm going to switch to red. So I have a hypotenuse, I have an angle, and I care about the opposite. So opposite hypotenuse is here. That tells me I'm using sine, because S is for sine. So sine, if you have an angle, it goes right here. The ratio is always between the two sides. This time it's opposite over hypotenuse, so it's x over 12. And we're going to cross multiply. 12 times sine 50 equals x. And you can just type that all into your calculator. 12 times sine 50 gives you 9.2. 9.2 kilometers is the height of the plane. So it's pretty awesome. So let's look at some more. We have a situation where we have a ladder and a wall. And we always assume walls and ground are at right angles to each other. May or may not be true, especially in my drawing. So let's say we've got a wall here. There's my wall. I've got the ground here. There's some grass. And if I lean a ladder against it, it usually looks like this. So there's my ladder. So conveniently, it makes a right angle triangle. So let's put in some values. The ladder is 3.5. It contacts the wall 2.8 meters from the ground. So this measurement is 2.8. And what are they asking me for? They're asking me for what angle does the ladder make with the ground. So ladder, ground, this angle. Okay, so now I'm going to also label this triangle with what these things represent. This is a hypotenuse because it's opposite the right angle. This is opposite the angle I care about, so it is an opposite. And this one's touching the angle I care about, so it's adjacent. Writing down my sheet up top, and I look to see which ones are important to me. And I see that I have hypotenuse and opposite, so I'm thinking here, looking for an angle using sine. Okay, so the math now is going to be sine theta is equal to opposite over hypotenuse, 2.8 divided by 3.5, and this time I'm going to set it up so I can do all the math all at once, which means that the angle must be equal to this angle finder button for sine. And you can type that all into your calculator with brackets, and you should get something like 53.13 degrees. All right, let's take it to the Cartesian plane. So a point 6, 9. We know that x, y is how we do coordinates. So we go over 6 in the x direction. That gives us 6 here. And we go up 9 in the y direction. So basically, we've defined a triangle. We're going to use this a lot in the next little bit. So we have an angle here. So 9 is our opposite, and 6 is our adjacent. And here's a hypotenuse that I don't care about as much. All right, so if I want to find this angle, and I'm just checking, yes, it's between the terminal arm and the initial arm, I'm going to use tangent because I have opposite and adjacent. So tan theta is equal to 9 over 6, which means that theta, the angle, must be arctan 9 over 6. And when you punch that all into your calculator, it tells you that angle is 56.3 degrees. Okay, and our final thing. Find all sides and angles of triangle DEF, given this information. So first I'm going to draw it the way I like to draw triangles. And I'm given that angle D is 90. So here's angle D, which means this is side D. And let's say F is here, and it's 38 degrees. And that means this little side is side F. And let's do angle E is here, side E is here, and it's 7 meters. Okay, so you can start wherever you want with this one. So I'm going to look for side D first, and I'm going to use my Casatoa trig ratios. Okay, so I'm going to do it relative to angle F. I'm not going to, angle E is easy to find, but I'm going to ignore it for now because I don't want to mess myself up, which means this is going to be an opposite, this will be a hypotenuse, and this will be an adjacent. So if I'm looking for side D, I'm dealing with adjacent and a hypotenuse, and I have an angle, so I'm talking about cosine. Cosine, the angle goes here. The adjacent is 7. I'm looking for D, and I'll just leave it as D. I do some cross multiplication. D times cos 38 equals 7, which means that D is equal to 7 divided by cos 38. And if I do that math, I get about 8.9 meters. Okay, next I'm going to find another side, little f. This time I'm going to use Pythagorean theorem. So I know that f squared is going to be the hypotenuse, which is d, d squared minus e squared, which is going to be 8.9 squared minus 7 squared. I do that math in the right order, and I should get 30.21, which means that if I take the root of that, f is about equal to 5.5 meters. Okay, so now I found another side. And if I want to find angle E, well, you can use trig, or you can just be lazy. Remember that angles in a triangle need to add up to 180. So you can do 180 minus 90 for the right angle, minus 38, and the leftover has to be angle E, which is going to be 52 degrees. And if you were really lazy, you just always know that one angle in a right triangle is going to be 90, so you can just do 90 minus 38 and get that 52.